Hi, welcome to another lesson with Dr. Hill. Today what we're going to do is we're going to do some alkene drawing problems, and we're also going to look at a couple of different ways of representing structures. So what we'll do is we'll go to the board, we'll look at the names of some substances, and funnily enough in this particular case the names of these substances can be a lot more complicated than the actual the structures that you can draw to represent these, particularly the line angle structures, which I'm going to introduce in this lesson. So we're going to look at the name, we're going to look at the full structure, drawing all the carbons and hydrogens out. We're going to look at the condensed structural formula, or the shortened structural formula. There's a couple of different ways of doing these, but the key is to try and be clear about the structure in your drawing of it. And then we're going to look at the line angle representation of the molecule, which is by far the simplest way of representing organic molecules, and you'll see it all the time in any practice tests you do for naming and stuff on the internet, because it's just the easiest way. So you need to get used to reading it if you're going to do higher chemistry, and you might as well get used to it now, because a lot of really good revisions available to you on the internet if you understand it. So without further ado, let's have a look at the board, and hopefully we'll be able to get this done pretty quickly. We'll do the first one. We're going to start with an alkane, and then we're going to look at an alkene, a couple of different alkenes, and we'll look at the names. So let's go over to the board now, and we'll see what the first problem is. Well, the first problem here is 2,3-dimethyl pentane. Well, let's have a look and see if we can figure this out. First of all, we need to identify the longest chain in this hydrocarbon. And we see the name pentane, so we know the longest chain is 5 carbons. So I'm going to draw out I'm going to give myself plenty of room to do the drawing. 1, 2, 3, 4, 5. Now I'll draw out my 5 carbons. Now it's a pentane, so when I see the ANE ending, that means it's an alkane, which means there are no double bonds and there are no triple bonds in this structure. So I'm going to put single bonds between all the carbons. All right, nice and simple. Now what we're going to do is we're going to try and figure out where our 2 methyl groups here. You see dimethyl, there are 2 methyl groups attached to this main chain, and they're attached at carbon number 2 and carbon number 3. So carbon number 2 has a methyl group and carbon number 3 has a methyl group. So let's put those on. I'm just going to make a longer line because then it gets a little bit less mixed up. And I'll do another long line down here to draw that structure. All right, so there's all the carbons in place. I've got my methyl group on carbon 2, I've got my methyl group on carbon 3, I've got 2 methyl groups, dimethyl, and it's a pentane. Okay, is that it could theoretically be, it doesn't matter which way we go, pentane is the longest structure. So now what we can do is put our hydrogens in. 1, 2, 3, 1, 2, 3. Always count your carbons to make sure you have 4 bonds in each carbon, no more, no fewer. Okay, so this one has 1, 2, 3, it has another hydrogen here. And then we'll look at the methyl groups. See, I've missed one here. Okay, and then we've got our 3 hydrogen here. 1, 2, 3, and our 3 hydrogen here. 1, 2, 3. So you can see that every carbon has 4 bonds to it, and each hydrogen only has 1. So that's our structure for this molecule. Now, the shortened structural formula, we can just do it. We do each carbon separately, and then the branches go in brackets. So I have CH3 for carbon number 1. This is CH just. You see, there's only one H attached to that, CH. And then I have a side branch, which goes in brackets, CH3. And then again we have CH. And then I have a side bracket, which is CH3. Then I have a CH2. And then I have a CH3. Okay, it's a bit cumbersome, but it is possible to draw out the full structure using the shortened structural formula. All right. Now the line angle formula is really quite straightforward. How do we do it? Well, what we do is the end of each line and the angle between lines represents a single carbon. So I start with putting my pen on the board, and I draw, that's my first carbon, 2, 3, 4, 5. Okay, so 1 carbon, 2 carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. 5 carbons. Okay, and what I have to do is I have to put side branches. Well, the side branches are just another line that goes off at a different angle, and in this case we've got one coming off the second carbon and we have one coming off the third carbon. You can go either side with this, but it's a bit easier, and that is that substance here, up here, 2,3-dimethyl pentane with line angle structure. Okay, so let's look at another problem. This is our alkene, and let's see if we can work this out. So pent-1-ene, so what I know is the longest chain in this, has 5 carbons, so I can draw them out. 1, 2, 3, 4, 5. I know it's going to have a double bond somewhere because there's an ene here. It's got one double bond because there's only one number there. So, because it is possible for them to have more than one double bond. But in this case, we don't go any further than a single double bond, and it's going to be on the first carbon. So I'm going to put a double bond in there, and the rest are going to be single bonds. All right. Now I have a side branch, a methyl side branch, 2 methyl side branches on the structure. I've got one coming off carbon number 2. Well, where's carbon number 2? It's here. It's not this one, because once you've counted your carbons for your double bond, the carbon numbers must remain the same for the rest of your naming system. So this is carbon 1 always from now on. So that means carbon number 2 is here, not here, right? It's here, 1, 2. So I'm going to have a side branch here. I'll give myself a good long one so we can draw it in. And on 3, we also have a side branch. And there it is. Okay, so that's all the carbons in. Now we have to put our hydrogens in. And again, let's just put the bonds in because we want to make sure every carbon has 4 bonds on it. Okay, this one has 2 bonds, so we can add 2 more bonds to that carbon. So it now has 4 lines leading away from it. That's 4 bonds. All right. This carbon has only 1 bond leading away from it, so it has room for another 3. Same thing with the methyl side branch over here. Now this one's interesting. This carbon, you'll see, has already got 4 bonds. We don't add any hydrogen to that carbon. This carbon, though, has 1, 2, 3 bonds, so we can add a hydrogen to that, an extra bond to that, and again 2, and then 1, 2, 3. So every carbon has 4 bonds around it. Then we can pop in our hydrogens. It's a bit tiresome doing it this way. This is why line angle formulas are so popular. All right. And people become very bad at drawing this once they get used to line angle drawings because they never use this again. But anyway, let's see if we can write out the condensed structural formula. So CH2, okay, C, this time just C, no hydrogen, but it's got a methyl group, CH3, okay, and then we have CH, and then a methyl group, CH3, okay, close the brackets, and then CH2 and CH3. And our line angle structure for this one, again, we start with the carbon number 1, put the pen on the paper, 1, 2, 3, 4, 5, okay, and then we have a side branch coming off carbon 2. That's a methyl group, so that just leads to 1 carbon, and off carbon 3, methyl group leads to that. Now we have to put our double bond in, and it's there. Okay, so that's our 2,3-dimethyl pent-1-ene, and let's see if we can race through another quick one. We have 3,3-dimethyl but-1-ene. Let's see if we can just work out the structure. So but is going to be 4 carbons, so 1, 2, 3, 4. It's got its double bond on the first. We are going to have 2 methyl groups coming off the third carbon. Remember, this has to be number 1, so that's going to be this one. So I've got a methyl group coming up here and a methyl group coming up here, so that's CH3 and CH3. Okay, that carbon now has 4 bonds. This carbon has 3 bonds, so we can give it another one. This carbon has only 1 bond, so we can give it 3 more. This carbon has 2 bonds, so we can give it 2 more. Okay, and we can draw in all our H's. The condensed structural formula is going to be CH2 for that one, then CH. Yeah, you have to work out that there's a double bond there when you use these structural formulas. There's nothing in a structural formula, the shortened structural formula to tell you that, but you should be able to work it out because you just have to complete the number of bonds. Then we go to C. Now in brackets we have CH3, but we have two of them, so we're going to put a 2 down there. Okay, and then finally we have a CH3. Perfect. Okay, and finally let's get our line angle drawing, because this is why it's so fast. So I've got 4 carbons. 1, 2, 3, 4. Lovely. Double bond there. Beautiful. Then I have 2 side branches coming off this one. And there you go. Job's a good one. All right, that was a wee bit more than 10 minutes, but it's good practice for these things. And I'll see you in the next lesson.